Today we learn about clock synchronous state machine. Okay, what is it? Okay, at first, let I introduce the basic structure of clock synchronous state machine. Okay, let's give some example. Maybe this one is so easy for you. Okay, at first, what is this? This one is this one is D flip-flop. Okay, D flip-flop. Let me use two D flip-flop connect at the same clock signal. Okay, same clock signal. That mean when clock tick, that mean when this clock tick, this flip-flop and this flip-flop will obtain the same clock tick. Namely, these two flip-flop will change the value at the same time. Okay. Assume that this one is Q1, this one may be Q2, for example. Then this one may be D1 and this one D2. Okay, because there are two flip-flop used in the circuit. So 1, 2 bit. That means Q1, Q2 maybe 0, 0. So 1, 1, 0 and 1, 1. Right? So for example, if now the value of Q1, Q2 is 0, 0. Okay, and D1, D2 maybe 0, 1, for example. Then when clock tick, what happened? When clock tick, this flip-flop and this flip-flop will read the data for input D at the same time. That means you read 0 at D1 and read 1 at D2. So when clock tick, Q1 then change to 0, Q2 change to 1. Okay. So now the value of Q1, Q2 then change to 0, 1. For the previous value of Q1, Q2 is 0, 0. But when clock tick, when read data from D1, D2, then it change to 0, 1. Okay, so we said that now the value of Q1, Q2 it change, or sometimes it's called it change change state. Now from now we will use the value of flip-flop Q1, Q2 output of flip-flop as state variable. Okay, state value. So Q1, Q2 in this case, Q1, Q2 are state variables. So if there are two state variables, namely 2 bit, right? So this circuit, will have got 4 state. Namely, when Q1, Q2 is 0, 0, 0, 1, 1, 0, and 1, 1. Okay, 4 possibility. So there are 4 states, and the state will change when clock tick. So that means when clock tick, these two flip-flop will change the value at the same time. So this kind of circuit then that is called clock synchronous state machine. Machine in this case mean the circuit, okay, that will change with some mechanism, and this circuit have got state, and the state will change synchronous with clock. Okay, so it's called clock synchronous state machine. Okay, now let's get back to the example for the structure. Now we know that the value of flip-flop, or the value of Q1, Q2 in this case, depend on the value of D1, D2 at the timing of clock tick, right? So if we want the value of Q1, Q2, for example, to be 1, 1, that means the circuit might get some value from D1, D2 with 1, 1, right? Okay, so in practical, the value that apply to D1, D2, or sometimes we call this signal as excitation signal. Excitation signal. Okay, to excite the flip-flop. Okay, and when the clock tick, the output of flip-flop, okay, will based on the input of flip-flop. Okay, where this excitation signal from? It form more circuit that connect to this one. Okay, that I name it as circuit F. This one, circuit F. Output of circuit F is excitation signal, and when clock tick, flip-flop will read data from excitation signal and update each value with the value of circuit F output. So circuit F usually is called next state logic. Circuit F then is called next state logic circuit. Okay, that means the output of F, okay, it used to determine, okay, the next state value of the circuit, or the value of flip-flop after clock tick. Okay, now how about the input of F? Okay, input of F maybe come from external input, for example input X or Y and so on, right? Okay, one of them is external input. And normally the output of flip-flop will feed back, okay, to be input of F, namely Q1, Q2. So input of circuit F or next state logic will maybe come from external input and state variable Q1, Q2. Okay, for example, now again, let's give some example. Now assume the current state or the value of Q1, Q2 is 0, 0. Okay, and this 0 feed back, okay, to be the input of circuit F, right? And maybe I apply input X as 1 and circuit F actually it is just a combinational circuit, with maybe AND gate, OR gate, or inverter inside. Okay, and this circuit will produce some output. Okay, maybe 0, 1. That means when clock tick, okay, these two flip-flop, okay, will get clock tick at the same time. That means these two flip-flop will change at the same time, namely D flip-flop, right? When clock tick, Q read data from D. Okay, now this flip-flop, D1 is 0, so it changed to 0. This one is 1, so it changed to 1. Change at the same time, okay? Same timing of clock tick. So it's called clock synchronous state machine. Okay, again, now value input, value of Q1, Q2 is 0, 1, right? So this value will update the value of circuit F. So now input of F, okay? Some part of input of F is Q1. Now it's become 0, Q2 become 1. So now the input of F change to what? Input X is 1, Q1 is 0, Q2 is 1. Right? It's changed. That means the output may be changed. Assume the output change to, for example, change to 1, 1. That means when clock tick again, now flip-flop read data and read D1 as 1 and D2 as 1. So it update data to 1, 1. Now it changed state, right? Okay, now state change. And the next component of clock synchronous state machine is one more combinational circuit. That will convert their state value to the final output of the circuit. Okay, that I name this circuit as circuit G. Circuit G also combinational circuit. Okay, that we should now output. Okay, we will based on the combinational value of its input. For example, the output may be red, green, and maybe yellow. For example, maybe connect to the red lamp or LED and green and yellow. For example, when the value of state variable Q1, Q2 is 0, 0. Okay, input of T is 0, 0. Maybe it give the output red. Okay, turn on. Maybe R is 1 and G is 0, Y is 0. Okay, when input is 0, 0. That means the state 0, 0 we will give the red lamp turn on. Okay, and when clock tick, the state may be changed to 0 1, and when 0 1, okay, apply to input G, then output may be the green, output may be turn on or become 1, for example. And when clock tick again, the output may be changed to 1 1, maybe change to 1 1. So when input of G is 1 1, output Y may be active. Okay, so it will return yellow lamp on, for example. So the circuit G then is called output logic. Output logic. Okay, and used to determine, okay, the output of the state machine is final output of the state machine. Okay, so then the basic, okay, structure again of state machine will part of 3 parts. The first one, state memory. State memory, okay, which can be implemented by flip-flop. So if you use 2 flip-flop, okay, there are 4 state. Okay, the output of flip-flop is state variable, and the second component is next state logic. This one is combinational circuit. Combinational circuit. Namely, the output will be based on the input value. Okay, combinational value of the input. Circuit F, okay, or circuit F. I will use, okay, circuit F for next state logic. The input of F may come from external input and state variable, namely from output of flip-flop. And the last component that used to convert state value to output of the circuit. Okay. This part is called output logic. Output logic. In this case, I name it as circuit G. Okay. This is the output of the circuit. This is the basic structure composed with state memory, next state logic F, and output logic G. For the design, you must design these 3 parts of the circuit: state memory, next state logic, and output logic. Okay, how to design? It's very easy. For state memory, you just, okay, determine number of flip-flop or number of state variable, okay, that need, okay, that are sufficient to or enough to number of state. For example, if you design something like traffic light, it maybe have got some condition or situation. For example, output may be red, green, and yellow. So maybe there are three possible output. right? That means circuit maybe have got 3 states. If the circuit have got 3 states, that means it need at least 2 bits, right? To represent that can represent 3 states. Namely, maybe 0, 0, 0, 1, 1, 1. Okay, and maybe 1, 0, but maybe we use or just 3, right? 3 value of state. Okay, we numerical the binary code that to represent some state or have some meaning. Okay, it is called state, okay, value or state code. And the value that you don't use or have no meaning, maybe it is called unused state. Unused state. Okay, and please keep in mind that circuit F, okay, is a combinational circuit. Okay, combinational circuit. So that means if you know the for example, numerical value of output and input, like a truth table, so you can design or determine or find out the equation, okay, for each output of F. That means you can draw the circuit diagram and implement circuit F easily. You have already got the knowledge or the skill of this, okay, before midterm examination, right? For circuit E also is combinational circuit. Again, if you know the relationship between output and input, so you can decide this one. Maybe use some K-map or something, or that you already study, okay, before the midterm examination. Okay, so this is just some basic component. And now let's see the detail. Okay, first, if the output logic G, okay, get the input just only from flip-flop, that mean, okay, look carefully, when clock tick, these two flip-flop, okay, you get the clock tick at the same time or simultaneously. That means Q1, Q2 will update value at the same time, okay, or change state at the same time. Maybe change from Q1 to Q1 star, Q2 to Q2 star. Okay, we use Q star for the next value, okay, or next state. Okay, after clock tick, right? The previous one before clock tick is Q. When clock tick, okay, it change to the new one, Q star. Okay, and when change the new state, that means input of G also change. And because G is combinational circuit, when input change, its output also change suddenly with some propagation delay. Okay, but for now, for uh, uh, easy to understand, okay, you can consider that when input change, its output change certainly. Okay, but just keep in mind that there is some propagation delay due to uh, some logic gate that connect inside in the circuit G. So the output, the final output of the circuit will change the value at the same timing of clock, right? Because when output change, when its input change, and its input is from flip-flop, right? From flip-flop, and the output of flip-flop change when clock tick. So output, okay, of this structure will change at the same timing of clock tick. This kind of state machine, okay, which the output is function or based on only state variable, namely G is the function of Q, okay, Q1 or Q2 only. Okay, this is a state variable. Okay, okay. G is function of state of the circuit only. Okay. This kind of state machine is more time machine. This one is more time, okay, state machine. But if circuit G, okay, get the input from external input too. So now what happened? When clock tick, output of flip-flop change. That means one part of the input of circuit G change, so its output change. Now output change when clock tick, and if external input change the value, that means some part of input G change. So output of the circuit can be changed also. Namely, the output can change when clock tick and when external input change the value. So in this case, G is the output, is the function of state of the circuit, and also depend on external input of the circuit. Okay. The circuit that the output based on state and external input value is called mirror type state machine. Type state machine. Okay. Okay, now let's back to the slide. Okay, this just shows some general structure of clock synchronous state machine. It composed with state memory implemented by flip-flop. In this case, maybe use general. We use D flip-flop and next state logic F and output logic G. The signal that from circuit F and applied to flip-flop is called excitation signal, and the output of flip-flop we treat it as state, okay, state of the circuit, and the circuit that the output based on state of the circuit only, namely the output based on the current state only. That means the output will change when state change or when clock tick. And this kind of state machine is more time machine. But if the circuit P depend on external input also, namely output may be changed when clock tick, which make state change, and the output also may be changed when external input change. And this kind of state machine is mirror type state machine. Okay, now let's focus on flip-flop that may be used as state memory. Normally we will use the flip-flop because it's so easy to use. Because what? Because the next value of Q is the value of D, at clock tick. Namely, it's D flip-flop, right? D flip-flop. This is clock. Okay. If you want Q to be 1 when clock tick, so you just apply, 1 at here. That means when clock tick, you register from D and see this 1, so it updates to 1. But if you want value of Q to be 0, that means you must apply 0, at D. Then when clock tick, Q register from D and see, oh, now it's 0, so it's updated to 0. So it's pretty easy, right, to use for H ticket D flip-flop. And in this course, maybe we use D flip-flop a lot. Anyway, if you use another flip-flop or latch, you can use. It's possible. And the equation that shows relationship between the output of latch or flip-flop and its input, it's called characteristic equation. You can derive characteristic equation by using each property. For example, for SR latch, and its function table may be something like this: SRQ. When SR is 0, so it's hold mode. Or the value of Q same as the previous one. When R active, now reset. When set active only, Q is 1, right? When SR is 1, 1, normally we don't use it, so you can treat it as don't care. So from this, the right equation for Q star. Q is current value. Q star is the new or the next value after clock tick. So, let's consider when current state is 0, SI is 0, so now it's the same, right? Nothing changes. Hold mode, right? Hold mode. That means the value of Q star will be the same as the current state or the previous one. Now, if current state is 0, so when input SR is 0, so Q star also 0. Or when Q is 1, Q star is 1. And when input SR is 0, 1, R active, right, is reset. That means Q star will be 0. And 1, 0 is set, right, will be 1. 1, 1 is don't care. So now you can determine the equation, right? Maybe you consider this one is what? S is 1, right? So it's S. And for this 1, maybe you select this one. So this one is what? Is Q, right? Q and what? R is 0, right? And R prime. That means Q star now is SR QR prime. Okay, this one. Easy, right? This one is characteristic equation for SR lat. And how about JK? For JK, it will be hold mode when JK is 0, 0, and when K is 1 is reset. When J is 1 is set. When JK is 1, 1 is toggle. Again, you can use Gmap to find out equation for Q star. Okay, Q star. For example, when JK is 0 is hold mode, right? It's hold mode. That means if the current state is 0, so next state is 0 also. If current state is 1, next state is 1. And when apply 0, 1, now K is 1, it's reset, right? So Q star is 0. 1, 1 is toggle. That means if current state is 0, toggle Q star become 1. If current state is 1, so it change to 0. And for 1, 0, 1, J is 1 is set, right? So Q star is 1. From now, then you can write the equation from Q star, right? By consider logic 1. Okay, I'll put 1. Maybe this term is what? Q prime and J, right? And this term is what? Q and K prime. Okay, and you combine these two terms, so you get equation of JK flip-flop as JQ prime plus K prime Q. Okay, get this one. And for T flip-flop with enable, for T flip-flop is Q prime, right? With enable, you also can determine the characteristic equation. For example, you can write the K-map something like this. Because T flip-flop have got only one input, right? EN is on EN. So maybe you can write something like this. It's Q, right? Maybe 0 or 1, and EN maybe 0 or 1, right? And for Q star, if EN is 0, so nothing change. The value of Q star will be 0, 1 at here, right? Because it's 0 at here, so it must be 0 at here and 1 at here. So it must be 1 at here, the same thing. But with enable active, 1 is toggle, right? That means if current state is 1, it change to, sorry, if current state is 0, it change to 1. If current state is 1, it change to 0. After that, you just select this term and this term, right? This term is what? This term, the product term of this one is EN and Q, right? EN, sorry, this is 0. This one is 0. EN prime, okay? EN prime and Q. And this term is EN and Q prime. Okay, combine these two terms together. So you get characteristic equation for Q star of T flip-flop with enable. Okay. Anyway, okay, basically we will use this, okay, H trigger D flip-flop for the analysis and design. And maybe sometimes we will use H trigger flip-flop, and sometimes we will use T flip-flop with enable. Okay, now let's see some example. Example 1. Let's consider this circuit. This circuit there are two flip-flop. That mean there are two state variable Q1 and Q0. So how many state of this circuit? Yes, it's 4, right? Maybe 0, this is the first state, 1 is the second state, 10 is the third state, and 11 is the fourth state. Okay, there are 4 states for this circuit because of 2 state variable. You can consider state variable. Just look, okay, output from flip-flop. And be careful when you consider output of flip-flop. We just consider just only one, maybe active high output, not count both 1, 2. No, because this output not independent from this one. Namely, if this output is 1, this output will be 0. Or if this output is 0, this output will be 1. Okay, it's dependent, right? So we don't count. We will count just independent variable. So for the simple one, you just count just only one output for each flip-flop. Okay. And input of flip-flop is called excitation signal. So there are two, D0 and D1. And this part of the circuit is next state logic F. And there is only one input, EN, in form external input, and one output, max. Okay, let's consider output max at first. Max is n function between Q1, Q0, and input input EN. Okay, EN enable. So because output based on external input, also this circuit is mirror type state machine. Okay, now let's do analysis. Okay, what is the result of circuit analysis? For analysis, normally we will give you some circuit. When you analyze, you must know the relationship between output and maybe input in general. But for state machine, you have more variable, not only output variable, not only input variable, but you have got state variable also, or output of flip-flop. Okay, don't forget this one, state variable. So your output maybe is the function of state variable and input. For example, output max equals Q1 and Q2 and input En. Okay, it's function of state and input, right? This is output equation. It's called this one as output equation. If you analyze combinational circuit, okay, the result of analysis maybe just output equation that enough. But for state machine, it's not enough. You need one more equations, okay, to determine the next state, namely when clock tick. Okay, you must know that when clock tick, what is the new value of state or next state, namely Q0 star and Q1 star. So you need to know this one, okay, when you analyze the circuit. This kind of equation that represent, okay, or to show that what is the next value of Q something, okay, it's called transition equation. Transition equation. Of course, it must be function of state and input. Okay, how to determine or how to get transition equation? Very easy. At first, if you use default like this example, Q 0 star equal to D0, right? By characteristic equation. This is characteristic equation of D flip-flop. And from the circuit F, you know that D0 equal to what? In this case, maybe you maybe consider this inversion bubble cancel together. This one cancel to this one. So D0 is this signal and this signal, okay, plus, okay, or add together. Actually, it's all right, all together. So D0 is what? This is from Q0 prime and En plus, okay, all right, En prime and Q0. Okay, this is the equation for D0. That means Q0 star then equals Q0 prime and En plus Q0 and En prime. Okay, that's all. Similarly for Q1 star also. Okay, Q1 star equal to D1, then equal to what? Output of this AND gate, okay, and output of this AND gate and output of this AND gate, okay, sum together. So, okay, the result is this one. Okay, for this one is output equation, right? And because it's function of state and external input, then it's mirror type. And this is characteristic equation, okay, because we use D flip-flop as state memory. And excitation equation, okay, if you consider just only circuit F, okay, its output is excitation signal D0 and D1, okay, for these equations. So it's called excitation equation. Okay, to show relationship between output of F, D0 and D1 in this case, and input of F. In this case is En and Q1, Q0. Okay, or output of flip-flop that feedback, okay, to F. And okay, when you substitute, okay, this term to this in characteristic equation, you will obtain the relationship between Q star to input and state variable. So you will get transition equation, okay, state transition equation of the circuit, Q0 star and Q1 star. Okay, this equation is very important because it explains the value of the variable when clock tick. Okay, now this is the result of the analysis. Okay, you must again know output equation and transition equation. And for more confident, normally from output equation and transition equation, you write down transition table, okay, to show numerical, okay, value of the state and next state, namely because there are two state variables. That means the possible state is 0, 0, 0, 1, 1, 0, and 1, 1. And next state, Q1 star and Q0 star. En is input. Okay, it's not input of the circuit. In this case, it may be 0 or 1, right? Now, based on this transition equation, you can determine the value of Q1 star and Q0 star. For example, if I want to build the transition table, this table is called transition table. So you can apply, right? For example, this 0 is from this equation by substitute value of En with 0 and Q1 is 0, Q0 is 0. So from this En is 0, 0 is here, 0 is here, 0 is here. So it becomes 0. This bit. And for this bit, or Q1 star, you just apply En 0, Q1, Q0 with 0, 0, okay, into the variable in this equation, and the result is 0, okay, and so on. Okay, apply all, okay, all of this. Okay, and to complete this table faster, maybe you may consider, for example, when because this equation is sum product, right? Sum of product. So you may be consider the condition that when this term will be 1, this expression will be 1 when what? Q0 is 1, En is 0, right? Or Q0 is 0, En is 1. So you just consider maybe En is 0, right? Q0 is 1. Q0 is 1 at here and at here. So it's 1, 1 at here. 1, 1 at here. And for this term, you make Q0 star to be 1 when Q0 is 0, En is 1. En is 1 at here, Q0 is 0 at here. So it's 1, 1 at here. Okay. You can consider something like this. Then for another place, it will be 0. And this term also, we try to find out the condition that will make this term become 1. For example, En is 0, Q1 is 1, right? En is 0, Q1 is 1, 1. Okay, so it's 1 at here. For this term, En is 1, Q1, Q0 is 0, 1. So 0, 1 is 1, so at here, Q1 star is 0. Q1 star is 1. And this term, En is 1, Q1, Q0 is 1, 0. Okay, 1, 1, 0 at here. You may do something like this, maybe faster. Okay, now this transition table. And sometime you may name, okay, give some name to this binary code. For example, let name state 00 as state A, state 01 as state B, 10 as state C, and 11, okay, as state D. That means the one is 0, right? Then you replace, okay, every state with 0 by A. Okay, for example, and 01, okay, change to B, 10 change to C here, and 11 change to D. Okay, when you change, okay, from binary to maybe alphabet or some name, okay, you call this table as state table. Okay, and one more table is output table. Actually, it is from Q1, Q0 is 00, 01, 1, 10, and 11. Okay, and from this output equation, max will be 1 when En is 1, Q10 is 11, 1, and 11 at here, so 1 at here. Another result is 0. And after that, okay, we just change, right, this state in binary to state name A, B, C, D. Okay, that's all. This is output table. So this is the result that you should obtain after do analysis. By the way, because the header of table, okay, of state table and output table, okay, is the same, right? Input and current state. So sometimes we merge, okay, these two tables together and become state output table. That means this state output table will obtain two information of next state S star, okay, next state after clock tick, and output value, okay, obtain these two information. When you use this state output table, you must focus, okay, one by one. For example, if you want to know the next state, you focus, okay, only this column which show the next state value. ignore another output of another column of output. Okay, so for example, if the current state is A, when clock tick enable is 1, so the next state is B, change to B. And if the current state now is B, when clock tick enable is 1, so it change to C. If the current state is C, and when clock tick enable is 0, so next state is Z. Okay, is C. At state C, when clock tick enable is 1, it change to state D. At state D, when clock tick enable is 1, it change to state A, something like this. And if you want to know the output, so you just consider only this column and ignore this one. Ignore the column of next state. Okay, just focus one by one. For example, if you want to know the output at state A when input is 1, so output is 0. If you want to know the output of state B when input is 0, so output is 0. At state C, when input enable is 0, output max is 0. And at state D, when input en is 1, output max is 1. Okay, something like this. Okay. Just focus only the column of the output, okay, and ignore the column of next state. Okay. And actually, there is one more representation for state machine and often used also. That is state diagram. How to write state diagram? At first, you maybe write state name with circle A, B, C, D. Okay, for state, and then you may be consider, for example, next state at first. At state A, when input is 0, let's go to state A. When input en is 0, let's go to state A. When at state A, when input is 1, let's go to state B. When en is 1, it change from A to B. Okay, something like this. At state B, when input is 0, go to B. When input is 1, go to C. So you can write something like this. When en is 0, go to B. When en is 1, go to C. At state C, when input is 0, go to C. When input is 1, go to D. When input is 0, go to C. When input is 1, go to D. And state D. When input is 0, go to D. When input is 1, go to A. En equal to 0, en equal to 1, something like this. Okay. For this example, it's very easy. When en is 0, okay, it keep at the same state, right? But when input is 1, it go to the next step in order A, B, C, D. Okay, and also you can write output and at the arrow, namely at state A, when input is 0, the output is 0. At state A, when input is 0, output is 0. Or this one, at state D, when input en is 1, input is 1, output is 1. So we write output max is 1 at here, okay, in the parentheses, something like this. So you can complete, okay, the analysis maybe by obtain output equation, transition equation, or this state output table or state diagram. And this one just give you some timing diagram. Timing diagram also important, okay, thing that you should analyze. Okay, to analyze the output, if the input and clock, okay, if you know input and clock, and let you determine the output, follow this timing diagram. At first, you must determine state. The state. For example, if this example, if it start from state A, and if the state machine change at positive edge of clock, right? Because this one we use positive edge, right? So the state will change when clock tick, right? So when you analyze the timing diagram, okay, you must, okay, constant effort the state change when clock tick at positive edge or negative edge. For the example, is positive edge, and let's start from state A. For example, at state A, at state A, at state A, okay, output max is 0. If someone maybe write something like this, and then we consider when clock tick, it change when clock tick enable is 0, right? So it's go to what? State A, input is 0, go to state A. So it's go to state A. And at state A, output is 0. Maybe someone do something like this. It's okay, but maybe it's because you must look the next state column and output column, okay? Alternatively, but maybe make you confusing sometimes. So for me, let you find the state for all period, okay, for all period of clock at first, and then after that, if you know the state of this, so after that you can determine the value of output easily, right? Because output also based on state. So for example, let's start from state A. When clock tick, en is 0, right? Then still be state A, okay? From let's write this one. This is positive edge, right, of clock. Okay. Now when clock tick into state A and continue state A until next clock tick. This clock tick is 0, right? So it's still to be state A until next clock tick. Now en is 1, so state A en is 1, go to state B. So change to B and still be state B until next clock tick. Now input is 1, state B input is 1, go to state C. Change to C and continue C until next clock tick. I mean this one, from this clock tick to this clock tick is state C. And when clock tick is 0, right, then continue C until next clock tick is 0, right? C also. For this clock tick, input enable is 1, so then it's change to what? C change to D, right? When input is 1, change to D. And when clock tick is 0, right, then it still be D. And clock tick is 0 right here, so it still be state D. And clock tick at here is 1, right? So it change to state A. And clock tick at here is 0, so it's state A. And after that, okay, you just determine the output. For this example, it's very easy, right? Because output max is 1, just state D, and input in is 1. So state D at here and in is 1 at here, right? So output is 1, just this, okay? And the other and another is 0, something like this. Okay, that's all. So you can determine, right, the result easily like this. And okay, for next example, for this example 2, the same circuit, but just delete this wire that connect from input to this AND gate. That means now everything is the same except the output. Okay, I just change the name from max to max. Okay. And this output max is what? Q1 and Q0. And you see that the output, okay, is the function only state, right? Only state variable. So this circuit is more type state machine. Okay, it just check only output equation. And for this circuit F still be the same. That means transition equation, okay, is the same. So this is output equation. This is transition equation. Okay, and when you write it down, state output table, please take a note. Okay, we write in this style, namely, we separate the output column, okay, to this one. Compare with the previous example. For the output table, output, okay, because output based on input value, so you have maybe 2 columns, right, for output max. But for more type machine, we call as state D for more type machine. Output is Q1 and Q0, right? Namely Q1, Q0, 004A, 014B, 104C, 114D. At state D, okay, output max, okay, is 1 at here and is 1 at here also. So please take this column is 0001. This column also 0001, right? The same. That means it's not depend on input value. So you can separate, okay, this output, okay, from input value, or make the new column separately. This is a style for more type machine. And for state diagram, you write down output inside the state circle, right? Inside the state circle, inside the state circle, inside the state circle. Okay, very easy, right? And to analyze the timing diagram, also you just, okay, find out the state for every period of clock first. When clock tick, what is the next state? When clock tick, what is the next state? After that, do just determine the output. For example, output max is 1 at state D. Okay, only state D. The output max is 1. So state D at here, output max 1 at here. Compare with the period. Example 1 is mirror type, right? At state D, the output will be 1 when input en is 1. So max for the example 1 is this one. But example 2, max is mirror, right? It's not depend on input. It's not input. So this is the difference between multi-type state machine and multi-type state machine. That the output based on the input or not. Okay, this is just for an example. And that's all for today.